Thank you to our exclusive AWS Deep Racer presenting sponsor Accenture, who has provided exceptional leadership and participation during the inaugural year of the AWS Deep Racer competition. They ran the largest private AWS Deep Racer league in the world. The Accenture AWS Business Group, AABG, is the driving force for the collaboration between Accenture and AWS and our joint customers through a one-of-a-kind partnership. AABG delivers the best of AWS's services and Accenture's unparalleled breadth and depth of industry and technology experience. So for more information, go to www.accenture.com/AABG. Hi, my name is Naomi and I'm the Digital Innovation Program Manager for Australia and New Zealand at Amazon Web Services, where our team helps AWS customers to develop new products, services, and experiences through using Amazon's innovation mechanisms. I am so excited to be able to be sharing this with you today to show you how you can get rolling on machine learning with AWS Deep Racer today. So my journey with AWS Deep Racer started around a year ago when I joined Amazon Web Services with little to no technical knowledge coming from a legal background, but I had a passion for machine learning and all things speed and racing. So Deep Racer taught me the fundamentals of reinforcement learning. It allowed me to get hands-on in the console to learn, and I'm also now a pit crew expert in Australia and New Zealand. So let's see what this session has in store for the pit crew today. So firstly, I'll be introducing you to the AWS Deep Racer. We'll go under the hood of the AWS Deep Racer car, and I'll teach you about how the AWS Deep Racer makes autonomous decisions and makes real-time choices. I'll also talk about the Evo and the new sensor kit, where it expands the learning and racing opportunities with new sensors that enable you to detect, enables the car to detect vehicles or objects in the way. I'll then share the exciting changes to the AWS Deep Racer League in 2021, where you'll have the chance to win prizes and also the chance to receive a free trip to reInvent. Then I'll introduce you to the concept of reinforcement learning and dive into the console using virtual racing and also the simulator and the architecture of Deep Racer. So I was so excited back in 2018 when Amazon SageMaker, remember that's the middle layer of the stack, added support for reinforcement learning, because this allowed support for Deep Racer. And Deep Racer literally puts reinforcement learning in the hands of everyday developers of all machine learning skill sets. But what is the AWS Deep Racer? So the AWS Deep Racer is a 1/18 scale robotic car which was launched in 2018 as a fun way for developers to learn more about machine learning. So even if you've mastered the Evo before, it expands the learning and racing challenges with ways to solve, with a stereo camera and a light detecting and ranging sensor, a LiDAR sensor. So if you have the classic AWS Deep Racer, all you need to do is to purchase your sensor kit and upgrade your Deep Racer to Evo functionality. Even if you don't have an AWS Deep Racer car like myself, you don't have to wait for a physical Deep Racer to start learning. You can now start in the console. So in the console, as you can see, there is a 3D racing simulator where building, training, and racing takes place. You can start to learn now to build models, and you can also race in the 2021 Deep Racer League. Each month, the top 3 competitors in the Pro Division win an expense-paid trip to compete for the Championship Cup at reInvent. Or you can start your own league of your own with the community races. The community racing tool allows you to build models to race with your friends, your colleagues, and just in July, any Deep Racer user can now create their own live races using the community racing tool. By creating your own live races in under 10 minutes, you can invite your friends, your colleagues, your sworn enemies to compete on the virtual track in real time. Race planners get access to tools to host their event, either in the console or on Twitch, and it provides you assets including overlays, you've got layouts, invitations, and also unique links for participation. They have easy customizable assets and which allow you to control the flow of races throughout the console. So racers can submit their models and control their speed multiplier to eke out the best performance whilst racing in real time. Now let's see what's in store for the Deep Racer League in 2021.
Since its first introduction in 2018, Accenture has been all in to educate developers on machine learning with AWS Deep Racer. In fact, we've trained over 2,000 of our own employees through a global competition in 2020 alone. That's why we're proud to present Deep Racer League in 2021, putting machine learning in the hands of every developer. Go.
Oh, wow. OMG.
Wow, that was really energizing. So today's session will prepare you to join the 2021 Deep Racer League. It will teach you how to make the fastest model where you get to compete against all racers around the globe. So there are two skills-based divisions to compete in. There's the open and the open in time trial and the pro, and then head-to-head. So the top 16 racers using the new Deep Racer live racing tool will get to compete on Twitch. Participants get to earn digital rewards, including body shapes, body wraps, paints, and even more exclusive rewards. Now, the top 10 racers in the open division will move to pro, earning a pro welcome kit with exclusive Deep Racer merch, including like sweatshirts, socks, stickers, and more. The top 10 pro racers each month will win a Deep Racer Evo car, and the top 3 qualify for the Championship Cup to join reInvent in 2021. So make sure you join the 2021 league to secure your spot on the podium at reInvent. Now, I'm sure you all want to learn about how to win. So let's get back to business and learn about reinforcement learning for the Sunday driver, which is what powers a Deep Racer. So since the 1950s, AI has transformed dramatically due to the emergence of cloud computing and also powerful compute capacity. Now, AI is extremely ubiquitous as enormous quantities of data is now available. It's present in everyday life, such as your smartphone, your Alexa, your transportation, and even in social media algorithms. So artificial intelligence seeks to create that human intelligence. And I know this is a broad concept. So one aspect that humans are really good at is learning how to classify or make simple predictions based on past behaviors. Machine learning is a subset of artificial intelligence that aims to replicate that exact human behavior. To burst your bubble, machines don't actually learn. What a learning machine does is it typically finds a mathematical formula which, when applied to a collection of inputs called training data, produces the desired output. So by using these statistical techniques to learn from the data, your model can build predictions and patterns which are really good at determining outcomes. So here on the screen, you can see 3 types of machine learning. You have supervised learning, unsupervised learning, and also reinforcement learning. Now, reinforcement learning is the one that you want to understand. This is what powers the AWS Deep Racer, and so we'll be diving deeper into this type of machine learning. So a little bit more about the types of machine learning. There are 3 main example categories. There's supervised learning on the left-hand side, which is about building a model to predict a value or to classify data. These models are trained using huge amounts of curated training data with labels attached to them. So, for example, you can feed this model thousands of images of a dog with the label dog attached to it. And over time, the model learns during training that a dog is a dog. And once it's trained during inference, if you feed the model an image, it can decide whether it's a dog or not. This you would have seen this in any image recognition or video recognition models. Now, for unsupervised learning, the models are trained to identify similarities in large amounts of data to help with classification. Unlike supervised learning, training data that's been fed into this model doesn't have this explicit label which tells it, for example, it's a dog. So instead, over time, the model is trained to identify these similarities in the images. So for example, if you fed this image, if you fed the model an image of a dog, the model will put it into a pile of dogs simply because it looks like one, but it can't really tell you that it is a dog. And this is used in fraud detection today. Now, lastly, on the right-hand side, we have reinforcement learning, where models are trained to autonomously predict which decisions to make in an environment. The model learns based on the outcomes of whether the actions are good or whether they're bad. And this is used in recommendation systems, in inventory optimization, and more importantly, in the deep racer model. So reinforcement learning is built on the idea that we as humans use most of the time. So if you can think of the last time you used a reward to incentivize the right behavior for maybe your pet or your dog. So think about the method that you use to train a pet. We give cookies for good behavior. We don't give cookies for bad behavior, and dogs simply just learn what they should or should not do to get the cookie. So when you're successful by teaching it the right behaviors, you can turn it into a circus dog, where it knows all the tips and tricks through getting cookies. So to be more detailed, reinforcement learning is a machine learning technique that enables an agent to learn in real time in an interactive environment by trial and error, using feedback from its own actions. And feedback is given in the form of rewards within the simulator. So within the simulator, we have an agent which acts autonomously in the given environment to reach a specified goal. In our case, the agent is the AWS Deep Racer vehicle, and the goal is to finish a lap around the track. Next, we have the environment, which is the surrounding area which our agent interacts within. In this case, the track is redesigned and also configured within AWS RubberMaker. And the agent essentially starts off on the track at the starting line, which we refer to as the initial state. So the state is defined by the current position within the environment, which is visible or also known to our agent, which then it can act upon. So basically, this is essentially what the agent can see through the camera. And for every state, our agent needs to take an action to try and achieve its, the best lap around the track. And depending on which action it takes, it's given a state in which it'll be given a reward. If the chosen action gets the agent closer to the reward, you can reinforce this action in the future through a positive reward, or otherwise discourage it with a negative reward, or just give it no reward at all. This reward is provided by the environment itself and is specified through the reward function written in code. And this is the most important part of training that you want to focus on. It's the written behavior, it's the written code to incentivize behaviors through parameters, which is defined by the creator of the environment. And I will show you a sample reward function later during the demo. And the last concept here that you want to understand is the episode, which represents each iteration where the agent goes from the start position to termination state. Termination state essentially means when it's driven off the track or it's completed a lap around the track. So these are all merely a collection of state action reward pairs. So the reward function incentivizes particular behaviors and is the core of reinforcement learning. To run your AWS Deep Racer car, providing a reward function will be your most important job. So let's have a look at this race grid. So to see a practical example, of the reward function. Each square is a state, and the green square that you see on the left-hand side is the starting position, while the finish line is the goal, the checkered one on the right-hand side, which is a termination state. The black squares at the top and the bottom of the track are defined as the stop states, which tell the track that tell the vehicle that's gone off the track or it's failed. The reward function is the actual code that you'll write that helps the agent determine if the action was good or whether the action was bad. And also tells you how good or how bad it was based on the outcome. So as the agent moves towards a goal, the next stage is evaluated and assigned a reward. This reward incentivizes the driving behavior that you want the agent to learn. So let's say we want the agent to drive on the center line. How would we do that? So you would do that by assigning a reward value to each state. And notice on each square there's a number, and through reinforcement learning, the car will learn which action results in the highest cumulative rewards on the way to the goal. So by assigning the highest reward in the center line, which is the number 2, our model will learn that the actions which stay on the center line creates the highest cumulative rewards, which leads to driving, which avoids it from driving on the sides. So let's see this in action. It takes a few iterations as well for the Deep Racer to learn. It takes trial and errors of multiple episodes or trips around the track, and you can see that the agent will need to explore where it can get the highest cumulative rewards before exploiting the knowledge. It will eventually reach convergence, where the model starts to frequently pick specific actions based on states. And notice on the reward graph on the left-hand side, you can see, which connects to your console, you can see as the episodes increase, the total rewards also increase as it learns how to get the highest cumulative rewards. After each episode, the agent gets the rewards and learns that the center line is the fastest way to finish and to go to the goal. So let's see what exploration and exploitation looks like. On the left-hand side, you can see the first-person view of what to expect during exploration. Driving off the road is common, hitting into walls is common. It's like teaching a dog how to walk straight. It might be painful to watch for the first few times, so you can leave it there to train for a few hours and come back to double check on how it's going. Now, on the right-hand side, you'll have exploration, which is a first-person view where you can see it's got a converged model, it's staying on the track, and it's, I guess, learning from the training process. So how does learning happen? You can see that on the diagram, it produces a model which tracks and navigates the highest rewards. The car interacts with the simulated racetrack environment during training and with the overall goal to get to the finish line whilst maximizing its total rewards. So Deep Racer drives around the track, it takes pictures that represents each state, and around 15 pictures are taken per second. So after each picture, the Deep Racer will take an action, like changing the speed, changing the steering angle. And the cool thing about the Deep Racer Evo is that it has a stereo camera and a LiDAR sensor. So it has more of an in-depth view of what objects are in front of it. And when the car ends up in a new state, it receives a reward based on the action it's chosen. And it's quite repetitive, so it normally takes around 20 episodes around the track. And you can actually control this amount of episodes using hyperparameters within the console. And the more it goes around the track, the more experience it collects, and at the end result, it produces a model. The more knowledge the model collects, the smarter it becomes, and it's able to figure out which action results and which state leads to the largest cumulative rewards. It then uses that knowledge to inform future driving decisions. Once training is finished, you will have a model that can be uploaded into your physical agent, which is the real AWS Deep Racer vehicle, that will then use the model to navigate a physical track in the real world. So how does this work? The AWS Deep Racer uses a neural network architecture with multiple layers to, I guess, if you think of it as a way for it to extract patterns from images, it tries to figure out which action leads to the best reward. So on the left, you have the input, which is a state, and there is an output, the action, which the action takes. The neural network arch looks like this. It's a simple 6-layer network. So first, the layer is an input layer, which is the image. It's normally a grayscale image, so you won't see color like this on the screen. But also when you have the Evo, you're actually getting 2 images instead of 1. and they're both stacked together. With the LiDAR sensor as well, you normally get another vector which shows the 90 degrees behind the cars, which helps it to know, I guess, what objects are around. From this input layer, it captures a pixel which goes through a 3-layer convolutional neural network to help identify the features from the images, needing to make, I guess, these driving decisions, like the track line, the center line waypoints, the field on track or outfield, and more. So it feeds these features into the second neural network and the policy network to help determine what action or what decision should be made during that to make the final output. So these decisions will inform whether the car should speed up, slow down, turn right, turn left, and the policy network then adjusts weights to help determine what action to take. And the weights are just as important as the amount of rewards that you give it. So these input values will help it to determine the actions. So let's talk a bit more about the Deep Racer console. So the Deep Racer console is an abstraction on top of API calls behind the scenes, which have multiple devices, which makes the AWS Deep Racer possible. This is already configured for you in the console, so you don't have to do this. However, the AWS SageMaker trains the reinforcement learning model. Then AWS RoboMaker provides the 3D simulation environment. They all communicate using Amazon S3, for example, the experience of the state, new action, rewards, and this is all generated into AWS RoboMaker. This is then used and trained the model is then trained in SageMaker. There are several iterations that go back and forth. So the AWS and the Amazon S3 stores the models, Amazon CloudWatch stores the logs, and Amazon Kinesis video stream is what displays the video in the console. And the most important piece about reinforcement learning is a reward function that you author during in the console using Python code. The great thing is that there are a few samples ready to jumpstart you. The 3 sample reward functions you can use to get up running really quickly during training, and the agent takes an action and the position of the car that is updated in the simulator. So the reward function is used to determine how good or bad the outcome is, and how the reward function would know whether the outcome is good or bad. Well, you can actually configure this for yourself using variables in the simulator. So you can use these variables inside the reward function. For example, you can tell it how close the car is from the center line track and how wide the track is as well. So you can give a higher reward for being closer to the center line, or you can give a higher reward for being closer to the outside of the center line. Behind the scenes, the rewards function is simply a Lambda function. You can make sure to validate the code as well, so it checks the syntax of the code before you save it and try to train with it. So let's have a look at the track components and the simulated measurements that can be used for your reward function. So how do we modify, how do we know what to modify? Which parameters are defined in the environment? And so essentially what you see here is the first-person view of the AWS Deep Racer, and this will tell you how to configure it as it drives on the track. So the main components of the track are the track wall, you have the field, you have also off-track, you have the track boundaries, and also the 2 lines around the track surface and also the center line. So that the track surface, these components are really important because we can use these to determine whether the action results in a good or bad outcome. Now, there are a few other components that we might want to look at. So the car has a X and Y position associated with it. We provide these waypoints spread around the track as a series of X and Y points to give some hints on the shape of the track. These waypoints help us programmatically determine how much of the track Deep Racer has completed, and so on. So we use these variables to build our reward function to determine whether the output was good or bad. Also, it's important to call out here that these variables are given by the simulator when we are training the model. So with the physical car, we don't have the simulator, we don't have these variables, within the real car. So we actually don't need the reward function. We just need the train policy and the model function to compute and to help the AWS Deep Racer car to make the next action from the camera input. So an example parameter would be a heading parameter, which describes the orientation of the vehicle in degrees. This is measured in counterclockwise from the x-axis of the coordinate system. And all wheels on track indicates if the agent is on the track and returns whether it's true or false. Distance from the center line then tells you how far away the vehicle is from the center line. And there are other variables available, such as like is reverse, progress, and you can use all these to build your reward function. So there is a new garage feature as well, where you can customize the sensors on your AWS Deep Racer and to create new cars with different sensor combinations, which is very cool. Adding different sensors means that your agent is capable of detecting different things. For example, it was difficult to learn the distance to an object, but now with the LiDAR sensor and also the two stereo cameras, you were able to gauge the distance. In the garage, you can set up the action space and the list of actions that it takes. For example, you have the combination speeds of angles, combination of speeds and steering angles as well. So the more actions you provide, the longer it will take to train the model, but potentially you'll get a better range of actions as the car is going around the track. The action space is set before training and can't be changed once it's already trained. Once again, I want to say a big thank you to our exclusive AWS Deep Racer presenting sponsor, Accenture, a global professional services company with a deep history of helping customers around the world build artificial intelligence and machine learning powered solutions with AWS. Accenture was named as a leader in the IDC MarketScape report, Worldwide Artificial Intelligence Services Vendor Assessment. And Accenture and AWS bring the best of both worlds to accelerate innovation in the cloud. Accenture has been all in on AWS Deep Racer since the inception and is proud to be the presenting sponsor of the AWS Deep Racer League in 2021. Accenture launched the world's largest Deep Racer League of 2019, featuring physical and virtual races in over 30 global locations. In 2020, they hosted their global private league virtually, and Accenture, an Accenture employee was also named as a top 3 finalist for the AWS Deep Racer Championship Cup at AWS reInvent 2020. So connect with Accenture at www.accenture.com/AI. Now, there are several resources out there to help you get started with AWS Deep Racer, and believe me, once you get racing, you won't want to stop. So I hope you enjoy spending time experimenting and tweaking your reward functions to move up the leaderboard. And like I mentioned, you don't need a physical car to start racing. You can start today using the AWS console, do it all virtually. So drive on over to the Deep Racer console and get on track and race for prizes and glory. I'll see you at the finish line. Thank you. Just a quick reminder to complete the survey to help us improve on future sessions and to let us know on what you'd like to see next. Thanks.